All right, AP Calculus, I'm sorry, AP Computer Science A. So we can do another demonstration together. This one's a really quick one. So we're going to open up BlueJ. So I'd recommend you having this on your screen, like half your screen, and then doing your own code at the same time. Now, usually if you open it up, it's going to open up with whatever is the last one. So I'm going to go ahead and close that. And we're going to go to project, new project. This is something just to get used to. Every program has its own project folder. Okay. So there's the last one we did together in P1A, which I kind of got you started on, which hopefully you've tried. We already have a unit 1 folder, so we don't need to create a new folder. So I usually just delete that and I say P1, we're going to call this one W. So we're doing these ones together at the end. P1WProject. And that's the way I want them. You should name yours that way too. And that creates a new folder. So we're going to go to new class. And this is where we can give it kind of more of a unique name. Let's call this one MaxValues. And it's by default regular class, MaxValues, camel notation. We're going to double click. We're going to open it up. Now, if at any point you can always pause this video to catch up. We're going to always delete everything that's in here. We're going to start by scratch. So every time we do this, and you should be hopefully, the more you do this, the more you're going to remember to do right away. So public class max values, it should have the same name that you just gave it, which you can see up here. Now, if you change it, if this doesn't match that, you compile it, I think that the name of the class will change to whatever you have in here. Curly brace, and we could go ahead and close the curly brace and comment it. I want every closing curly brace commented. Okay, end class max value. So to say what the curly brace is ending, this is a class. Now in here, I'm going to tab in. I would go to options and change the auto indenting, turn it off, and just use the tab button. Tab button is right above the caps lock button. Public, this is always going to be the same, static void main, parentheses, space, capital S string, args, regular brackets, space. Okay, so we're going to do that every time. As we get further in this class, I will be able to tell you what some of those things mean and you'll understand them. So end method main. So that's called the main method. There's the name of the method. Okay. Public, just that's the visibility of it, because we can actually write things that are private. I'm not going to get into that yet. Okay. Now let's put some comments here. So I'm going to say, I'm going to show you a couple things here. So this is a loop, and this loop will alternate will alternate between positive and negative values. Okay, there's just some notes that you can have in here. Demonstrating the clock effect of primitive variables. Now, primitive variables are the ones that we've been using to store numbers in. Int, double, Boolean. Strings are not primitive. They're objects. You can also try a byte in place of short. If you want to test your vision. Let's see what I mean in a second. Okay, so there's just some comments here. Now, this is something that we'll be talking more about, and I'll be showing this in some other, demonstrations we do together. But we use something called a for loop. So this is a loop is a way. A loop is, you keep going around a loop, right? And so this is something where we're going to do something repetitively. And a for loop is one way of doing that. And we'll talk about other kinds of loops too. So it starts with for, this is the for loop, and then parentheses. Now inside, we have to create sort of like a counter that will keep track. But you got to say what kind of, it's going to be a number. You got to say what kind of primitive variable you want. So far we have ints and doubles, but there's actually a short, is a smaller type that we're not going to really use ever again, probably after this in this course. And we give it a name. I'm going to call it CTR for counter. You could get any name you want. I'm going to call it CTR for counter. And we'll initialize it at 0. And then you put a semicolon. And then in here, we're going to run a test. We're going to say, we want to keep doing this as long as the counter is less than, let's say, I think I'm going to do 10 million. So did 7 zeros, 1 with 7 zeros, semicolon, and then we have to have some mechanism that will increase the counter every time we do something. So we'll do counter. This is a shortcut plus plus. That means we're going to add, I'll put a little comment here, plus plus adds 1 to the previous value. So we call it an incrementer. It increments it. Now a for loop has its own curly braces. Every kind of structure in Java is going to have its own curly braces. And let's go ahead and comment the ending one right now. End for. We'll just say end for. Okay, now in here we're going to do something repetitively. We're going to do system.out.println, and we're just going to print the value of the counter. Semicolon. I'm going to just print the value of the counter. Now, the reason I chose short or byte is because those numbers can't get as big as, say, an integer. We printed out the max value and the min value for an int, and that was like 28 billion or something like that. So this is a little. This one doesn't get as big. So this is going to keep adding 1 to counter, and then once it's equal to 10 million, it should stop. So usually for loop should stop. So let's go ahead and if you have this typed up, like I said, pause it and get caught up if you need to. And so we're going to compile it, upper left corner, and we're going to close this. Usually we're going to use an integer, not a short. We're usually going to use an integer for our for loop. So this is just I don't know. This just shows this effect quicker, this clock effect. So we're going to go over here. We're going to right click, select void main string, left click on it. Okay. And those are the counter values, but look what happens. And by the way, we can, this looks like it's never going to stop, and it won't. So you could, but you'll notice that there's negative values, like the numbers get bigger, 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 and then they get negative, and then they get bigger, bigger, bigger. So if you go over here, you can right click on, I don't know if there's a way to pause this. If you say reset virtual machine, I think that'll stop it if your program just runs forever. But we could go back to this window and it just kind of freezes. Well, it won't show you everything that's printed. It kind of only prints a certain amount of lines, but the numbers are getting bigger, 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 right? I wonder if there's a way. Okay, so what happens is once you get to the number that is too big for Java to handle, instead of it crashing, it kind of has a little thing to help it avoid crashing. I don't know if it's that great of a situation that it creates, but what it does is once you get to the biggest number that Java can possibly hold for that type of primitive data type, it then will automatically jump to the smallest value and then start increasing again. So once we got up to whatever the biggest size was, it jumps to the smallest value it can hold, which is probably not what you want it to do. But it is a kind of a mechanism for Java to not crash when that happens. I don't really think that option is better, but they call it a clock effect because it's like it's going around and around and around. So we could go in here and, like I said you could change it to like a byte, which is even smaller than a short. So that means it's going to happen even quicker. So we could compile that and then close it and then right click, select void main, left click OK. See, bytes are even smaller. They can only hold so much. They're a smaller type of memory. So you can see it turning to negative. I don't know if we could stop it just at the right time. Maybe we could see it change from positive to negative or something. I don't know how easy that would be, but it's getting bigger, bigger, bigger. No, we kind of missed it. Maybe if anyways, I'm not going to try that. But so that's just kind of interesting. This is also introducing you to a new concept called a for loop that does something over and over again. I mean, this was very simple. We're just printing out the values, but it has some sort of like counter or something to keep track of how many times you've done it. And you need some condition to tell it when to stop. And then you need something that tells it what to add to the counter. And you could add more than just one each time, but adding one each time is a very common kind of scenario. You want to do something 10 times, set the counter to 0, less than 10, and 0 is the first time. You could start at 1 if you want, but 0 is usually a common starting point. And then the plus is just a shortcut for saying add 1 to the counter each time. So that's it for this one. I'll be showing you another more substantial video coming up.